Okay, this video is going to be on polynomial functions, and we're just going to jump right in. So you need to be able to write a polynomial, so a group of junk here, in standard form. What standard form is, the standard form of a polynomial function is just, you could ignore these terms here, we're going to learn those on the next slide, but it's just, in the long and short of it, arranging the terms by degree in descending numerical order. What does that mean? Well, the degree is the exponent of a variable. Exponent, I'll just write it, it might be easier. A degree is the exponent of a variable. And so what you're going to do is you are going to put them in order from biggest to smallest, essentially. So you can see here, here's a variable with an exponent of 3, variable with an exponent of 2, variable with an exponent of 1, and then there's no variables with no exponent. So the degree is 3, 2, 1, 0. And you want them to be in that descending order. So is this in standard form? No, because it goes 0, 1, 2. So that is not in standard form. But this one is, because it goes 2, 1, 0. Same with over here, 2, then 1. That is in descending order. It goes from biggest to smallest. So you need to be able to do that. You need to put it in standard form. Once it's in standard form, you're going to classify it. So you can see here I have a list of polynomials that are in standard form, meaning they're in biggest degree to smallest degree. If their degree is 0, then it's called a constant. So when I ask you in the test, classify by degree, you better not tell me that it's a 0 degree. You better tell me that it's a constant. So this has no variable, meaning no degree, meaning constant. If it has an exponent of 1, that means it's linear. An exponent of 2 means it's quadratic. An exponent of 3, and you're just looking at the highest, the first term. Once it's in standard form, what's the degree of the first term? Because that expresses the degree of the entire polynomial. Degree of 4 is a quartic, and a degree of 5 is a quintic. That's all I'm going to require you to memorize, 0 through 5. Anything higher than that, 6 to n, meaning 6 to any number you want, just say it's that degree. It's a 6th degree, or it's the nth degree. So if it's x to the 100th power, it would be the 100th degree. After you have the degree satisfied, you're going to do the number of terms. And the number of terms are represented, let me erase these marks here so we don't get confused. The number of terms are represented by the actual number of terms. And it's usually separated by an addition or subtraction sign. This right here is still one term because there's no addition or subtraction. It's just the term 4x squared. That is itself is a term. So you can see 1, 2, 1, 3 terms here, 2 terms, and then down here 4 terms. Basically, I want you to memorize the first 3. 1 term is a monomial, 2 terms a binomial, 3 terms a trinomial, and anything after that, so 4 all the way down to n, you would say it's a polynomial of 4 terms, or a polynomial of n terms. So if I have 100 different terms, I would say that's a polynomial of 100 terms. So let's do some practice here. This one, we first need to write it in standard form. Negative 7x squared plus 3x plus 6. Now that it's in standard form, we can classify it. And we want to classify by looking at the number of terms, 1, 2, 3, and the degree of the leading term, 2. That means it is a quadratic because of the second degree and a trinomial because of the 3 terms. So we'll classify it as such. This is a quadratic trinomial. That is how I expect you to classify this if you want credit in this class. Here, it's already in standard form, 5, 4, 3, 2, 1. So we don't have to rewrite it in standard form. We just have to look at the number of terms, 1, 2, 3, 4, 5. And we need to look at the degree of the leading term, also 5. So to classify this, we will call this a quintic polynomial of 5 terms. Again, that's what I expect to get from you if you want full credit. Quintic because of that degree of 5, and polynomial of 5 terms because there are 5 terms. Great. Once you have them classified, we are going to talk about end behavior. And the end behavior deals with this a value. The a value is the number in front of the leading coefficient. So the a value here would be -7. The a value here would be 4. That's going to help determine our end behavior. When that a behavior is positive, it tells us that the right side is going up. So the right side of our graph, we don't care about what happens in between, the right side will be going up. If that a value is negative, it tells us that the right side goes down. Right side goes down. And then we look at the degree. That's what they call n. The degree. If the degree of your leading coefficient, so in this example, the 1, in this example here, the 2, in this example here, the 5. If the degree is even, then the left is the same as right. If the degree is odd, then the left is opposite of the right. It's not the same as the right. So let's just put that into practice. I have x to the 4th. My a value is positive, meaning the right side of my graph will end going up. My degree is 4, meaning my left side will be the same as my right side, also up. We don't know what goes on in the middle. That's for later in math. For now, we just want to know that the ends are going up and up. So left side up, right side up. It's always left then right. Here, the a value is negative. So that means my right side is going down. My degree is 2, meaning my left side will be just like my right side. Down and down. And you can see that graph is down and down. Moving here, my a value is positive, telling me my right side will go up, but my degree is odd, telling me my left side will be opposite. So my end behavior is down and then up, because you always go from left to right, down and then up. And then lastly here, this negative means my right side is going down. This index means it's opposite, so the left side goes up. So my end behavior is up and then down. Awesome. And so the one last thing, if you're a CP student, is end behavior. And so I've already classified this. It's in standard form as a cubic polynomial of 4 terms. It's cubic degree, and it has 4 terms. So we need to look at the end behavior and the max number of turning points. Well, the maximum number of turning points, is 1 less than degree. And you can see that up here in the example above. When it's linear, the degree is 1, and there's no turning points because lines don't turn. When it's a degree of 2, it's a parabola, and you can see it turns 1 time. A degree of 3, 3 minus 1 is 2. That means it has a maximum number of 2 turning points. And you can see this example does turn twice. This one only turns once. But the important thing is that the max turning points is 1 less than degree. So let's look at this, kind of put it all together. In this polynomial here, we have 4 terms, so it's a polynomial of 4 terms, and the degree is 3, so it's cubic. The end behavior, my a value is negative, so my right side will be going down. My degree is odd, so my left side will be opposite of my right side. And the degree is 3, so I'll have a maximum of 2 turning points. Maximum of 2, but I could also have 1. So the end behavior of this graph is up and down, and there are 2 maximum turning points. There could be 1 turning point. If you're CP, you can stop right there. If you're honors, you need to move on to the next page for one last thing. And so I've got here a table. And if I wanted to find the arithmetic sequence or the common difference to see if it is arithmetic, I would take this term minus that term, and this term minus that term, and this term minus that term to see if there's a common difference. And if there is a common difference, it's arithmetic. Well, if there's a common difference at first, it's linear. And so we'll look. I've started taking the differences between all of these. So the difference between negative 13 and negative 10 is negative 3. The difference between negative 12 and negative 13 is positive 1. The difference between 29, so 29 minus negative 12 is 41. Are these numbers the same? No. So there is no common difference. This is not arithmetic, meaning it is not linear. If these all were the same, it would be linear. So now we move on to the next line. 1 minus negative 39, that's a difference of 40. 5 minus 1 is 4. Negative 3 minus 5 is negative 8. 1 minus negative 3 is 4. And 41 minus 1 is 40. Definitely a pattern here. 44, negative 8, 4, 40. Definitely a pattern. But are all these numbers the same? No. So it's not quadratic. If the difference of the difference, meaning the second level of differences, the second set of differences, if they were all the same, it would be quadratic. Now we move to the third. 4 minus 40 is negative 36. Negative 8 minus 4 is negative 12. 4 minus negative 8 is 12. And 40 minus 4 is 36. Again, definitely a pattern. No one's arguing that. But are all these numbers the exact same? No. If they were, if the third difference were all the same number, then it would be cubic. So now we move on to the next level. Negative 12 minus 36 is 24. 12 minus negative 12 is 24. 36 minus 12 is 24. Are all these numbers the same? Yes. That means it is a quartic. That means it has a fourth degree. Fourth difference means fourth degree. That means my graph will have x to the fourth in it in some way, shape, or form. All right, and so you need to be able to use, these are called the common differences. And so I know that this table right here represents a quartic function, or a function of the fourth degree. So you'll have homework on that. Please let me know if you have any questions. You just keep taking the difference. This term minus that term, this term minus that term. You just keep doing that each level until you find where it's the same. In theory, it should always get the same if you have some sort of x to the some power. You'll see where it could be a little different if we had maybe logarithmic or natural logs or exponential functions. But all right, that's all for the video. If you have any questions, let me know. Goodbye.